All right, so the first thing we have here are real number subsets. In subsets, every number that we talk about here are going to be real numbers. There are imaginary numbers. We're not going to talk about those, so whatever we have is going to be a real number. And then they're either rational or irrational. Irrational numbers are numbers that go on forever without repeating. They can't be written as a fraction. So examples would be like pi. Other examples would be like square roots or cubed roots that aren't a whole number. So like square root of 2, like we don't know that. It's not a perfect square. So it's going to be a decimal that actually goes on forever. Rational would be any decimal that stops, repeats, any fraction, any whole number, all of those, anything that stops or repeats is rational. And then integers would be the next part of that. Integers are part of rational, okay? Except integers don't have the fraction or the decimals. They're just negative whole numbers and positive whole numbers, and 0. And then the next subset of that, so it gets a little smaller, is whole numbers. Whole numbers, we take away the negatives. So we just have 0 and positive whole numbers. And then natural. Natural is the same thing as whole, but natural does not include 0. So natural is anything that you would say if you started like counting. So like 1, 2, 3, 4, all the way to infinity. So this table right here is going to be something good to look at while you are doing the work. So we're just going to go through a couple of these and classify them. So -8. So if we look at it, -8 definitely is real because all of them are real. So we'd write real. Okay. We'd write rational because -8 stops. Does not go on forever. Okay, -8 and then getting smaller. So we're just going to start on integers and work our way in. -8 is an integer. And then whole numbers. It's not a whole number because it's negative. So now we can stop. Those are the 3 things that it is. So starting with the next one. Square root of 13 is real. It is a real thing. Okay, and then since it's a square root, we need to double check. Is it a square root that we know or don't know? So if I think to myself, what times itself is 13? 4 times 4 would be 16. 3 times 3 is 9. So 13 fits somewhere in between 3 and 4. So we don't 100% know what it is. It is a decimal. Since it's a square root we don't know, it's actually a decimal that goes on forever, which means it is irrational. Okay, next one, 0.45 repeated. So that is real. 0.45 repeated is also something that stops or repeats. And anytime anything stops or repeats, it's rational. And then I would go to integers, like work your way in from there. It's not an integer because it has a decimal. So since it has a decimal, it's not an integer, it's just real and rational. All right, next one, let's just look at one more here. It says, give a number that is rational but not an integer. So we kind of just talked about that. So it would be anything that's a decimal that stops or repeats. But it isn't a whole number that's positive or negative to make it an integer. So 0.67 stops or repeats, but it's not an integer. And then you're going to want to look at your notes for these properties, okay, when we're doing these. Anytime anything says identity, the big thing is the number itself doesn't change. So additive identity would be adding 0 because the number doesn't change. Multiplicative identity is multiplying by 1 because the number does not change. Multiplicative property of 0 is just timesing by 0. It's equals 0. And then additive inverse would be adding like the opposite of any number. So the opposite of 5 would be -5. The opposite of -7 would be +7. Multiplicative inverse is multiplying by the reciprocal. So taking that fraction or number and flipping it upside down. And then a lot of these are somewhat similar. I think you can look on here for the rest of them. There's a whole long list. They're on your notes, and I think it's easier probably to look at them as you're going here and kind of figure out what they are. So name the property illustrated. So this one's multiplying by 0. And for this one, it's okay to abbreviate. It's going to be the multiplicative property of 0. Okay, the next one, this x does not change. And anytime it didn't change, we know it's going to be identity. And then we're going to look at what we're doing. Are we adding or multiplying? Well, we're adding. So it's additive identity. Okay, next one, same thing. If we look at it, this 5 did not change, so we know it's identity. And this time we are multiplying, so it's multiplicative identity. Okay, if we look at the next one, is a times b equals a times b. It's the same exact thing on both sides. So what I would do if I didn't know these is I would go back and look through my properties. Which one has the same exact thing on both sides? We know this one's a equals a, same thing on both sides. So I'm going to write that one down. Okay, so it's the reflexive property. So I'm just going to write reflexive. So the next one, if 12 equals 10 plus 2 and 10 plus 2 equals 6 times 2, we know that 12 is also 6 times 2. So if we notice, this one's kind of like a chain. If this equals this, okay, and then it's the same thing equals a third thing, we know the first equals the third. Okay, so it's like a chain. And anytime it's like a chain, we see that one right here. First equals the second equals the third, we know the first equals the third. Okay, so anytime it's like a chain, that's going to be transitive. Okay, next one. We know if x equals 2, then we can kind of take the same equation here, and we can sub x out and put in 2. Okay, so if these two things are equal, we can just replace it in an equation. Okay, so if we look up here, that's just going to be substitution. Okay, so that one's, I think, kind of easy. So if two things are equal, you can substitute one in for the other. And then the next one, if we notice, it's the same thing, right? But on this one, the 8 comes first, and the 6 plus 2 is second. Now the next one, the 6 plus 2 is first, and the 8 is second. So again, if we look up at our properties, equality is symmetric. So A is first, A is second, B is second, B is first. So it's just the symmetric property of equality. So I'm just going to write symmetric. Okay, and we could go on and on here. I'm going to do some of these, and you can copy them down from the notes, but if you have any more questions, just ask.